Now we are going to start a new topic, that is rotation of frame. So in physics, whenever we describe a motion, we must first decide from where are we observing it. So this from where is called the frame of reference. Now it is simply a coordinate system with x, y, z axes, relative to which we measure the position, velocity and acceleration. Now imagine, instead of observing motion from a fixed coordinate, we observe it from a system that is rotating. That is what we call a rotating frame of reference. Now the most natural and practical example of a rotating frame is the earth itself. The earth is constantly spinning about its axis. So when we study motion on earth, we are actually studying it from a rotating frame. So now actually when we rotate the frame, the object does not move, does not change actually. The motion does not change, but the description of motion changes. So mathematically, when we rotate a coordinate system, the components of vectors changes, but the vector itself remains the same. This is the very deep idea of rotation of a frame. So physics does not depend on how we choose our axis. The laws of physics remains basically the same in all frames, but their mathematical form may look different. Now let us consider a XYZ frame with X being this, Y axis being this, and Z axis being this. Now the frame is rotated about Z axis, so by an angle theta. So the Z axis basically does not change. So if it is rotated by about Z axis, then this Z axis won't change. What would change? The X axis would become X prime. The Y axis would become Y prime, and the angle between X and X prime would be theta. Similarly, the angle between Y and Y prime would also be theta, because the frame is rotated about Z axis by an angle theta. So now coming to equations. Basically, we need to find is the rotated coordinates, right? So we need to find X prime, Y prime and Z prime. So as Z prime doesn't exist, so Z prime will be equal to Z. So what we actually need to find is X prime and Y prime. So considering X prime, what we can write is X prime is equal to X cos theta. How come X cos theta? Because the angle between X and X prime is theta. So X prime would be X cos theta plus Y cos 90 minus theta. Why 90 minus theta? Because if you carefully look into the diagram, you will see that the angle between X prime and Y is theta less than 90 degree. So initially the angle between X and Y was 90, because X, Y, Z are orthogonal coordinate system.
So angle between xy, yz and zx is nothing but 90 degree each. Now as we shift x towards x prime, as we shift x from x to x prime, the angle between original x and x prime is theta, and the angle between original y and x prime will be nothing but 90 minus theta. Alright, so this is how we write x prime. So what will this actually change to is, it will become x cos theta plus y cos 90 minus theta is sin theta, sin theta. Now similarly, if you look into the y prime axis in the same way, just to now y prime would become, what it would become, nothing but, what is the angle between y prime and x axis? So it would become x cos 90 plus theta plus y cos theta. How come? Because as you can see that y prime is making theta degree with y axis, and y axis is making 90 degree with x axis. So y prime would be making theta degree with y axis and theta plus 90 degree with x axis. So what this changes into is y prime is equals to, now cos 90 plus theta is minus sin theta. So minus x sin theta, this is basically basic trigonometry, plus y cos theta. And what will z prime be? Z prime will remain z, because the coordinate system is rotated about z axis. So the z prime will, the z axis actually doesn't change. Now let us make a matrix of these coordinates. So on the left hand side, what we want is actually x prime, y prime and z prime, right? And on the right hand side, what we have is, so this is basically cos theta, because let me explain it. Why cos theta? Because the coefficient of x in the x prime equation is cos theta. The coefficient of y in the x prime equation is sin theta. And does it have any z coordinate? No, so it will be a 0. Similarly, the coefficient of x in y prime's expression would be minus sin theta, and the coefficient of y in y prime's equation would be cos theta, and the coefficient of z in the expression of y prime is there any z? No, right? So its coefficient is 0. What about all of these for z prime? So z prime only has z, which would be 1. And does it have any x prime, x and y coordinate in it? No, right? So sorry, so that changes to 0. So if there's no x and y term, their coefficients become 0. So in short, we can write that x prime and y prime is equals to cos theta sin theta minus sin theta and cos theta. Okay, there's one more matrix here because we need to multiply this. Sorry, we need to multiply this matrix with another matrix which is nothing but x, y, z. So this x, y, z matrix again appears on the second line of the equation like x, y, z. So how can this equation be represented in the matrix form? How can this equation be represented in the matrix form? And how can this equation be represented in the matrix form is what we did here. And shortening it up, this changes to, this changes to x and y because there wouldn't be any z term as we have already condensed the matrix. So this matrix is nothing but cos theta sin theta minus sin theta and cos theta with x and y. So condensing it more, we can write that x prime is equals to r into x, where r is nothing but the rotation matrix. So this cos and sine terms basically represent what? Nothing but the rotation terms. So these are the rotation matrix. So R is equal to, so writing only the rotation matrix would make us write cos theta sin theta minus sin theta cos theta. That's it. So what would be the determinant of rotation matrix? That would be cos square theta plus sin square theta, and we know that cos square theta plus sin square theta is equals to 1. So this is what we need. So basically every rotation matrix have a determinant 1, and any transformation, for any transformation to be rotational, its matrix should have a determinant of 1. Now for reflection, that is space inversion. So what basically happens in space inversion is x changes to minus x, y changes to minus y, z changes to minus z, and when it happens for a reflection about x-axis, x will change into minus x. For a reflection about y-axis, y will change into minus y. For a reflection about z-axis, z will change to minus z. So reflection, so basically what happens, and in order to find the reflection matrix, just like we did in rotation matrix, change the rotation matrix. Like for rotation matrix, the matrix was cos theta sin theta minus sin theta and cos theta, right? So after reflection, what it will become is just these two components will have a negative sign with them. So what it becomes is the upper two terms remains the same, cos theta and sin theta, but then the lower term, that is minus sin theta, changes to sin theta because it has got a minus sign already multiplied with it, and cos theta will change to minus cos theta because cos theta will also have a multiplication of minus sign with it. So this R prime basically stands for reflection. So finding its determinant would make us know that its determinant is nothing but minus cos square theta minus sin square theta. So it is nothing but determinant of R prime, that is determinant of the reflection matrix, is nothing but minus 1. So determinant of the rotation matrix was plus 1, determinant of the reflection matrix is minus 1. So this is all we have to remember. So that's it. Let's meet in the next video lecture.